Welcome to Cognitia, the channel where curiosity meets understanding. The human immune system is one of the most complex biological systems we know, second only to the human brain. Yet despite how essential it is to our survival, most of us never truly learn how it works or what it actually consists of. Your immune system is not a single organ. It is a vast, distributed network made up of hundreds of tiny organs and two major ones woven throughout your entire body. It has its own highways, checkpoints, factories, and communication systems. Every single day, it produces hundreds of billions of new cells, organized like a highly disciplined army with frontline soldiers, commanders, intelligence officers, heavy weapons, and even cells designed to sacrifice themselves for the greater good. Your immune system is not an abstract force. It is you. It is your biology constantly defending you from billions of microorganisms that want to consume your resources, hijack your cells, and reproduce at your expense. It also protects you from your own cells when they malfunction and begin turning into cancer. The system is so vast and interconnected that it cannot be fully explained in one video. This is why this story begins a series today. We follow what happens when your body is invaded and your first lines of defense are pushed into a fight for survival. It's been a normal day. Then suddenly, the world explodes. An asteroid tears the sky open and alien invaders pour in, destroying infrastructure and overwhelming civilians. This is what your cells experience. You look down at your thumb. You cut it on a dirty twig in the park. It barely seems worth noticing. But inside that wound, a biological disaster has unfolded. Cells have ruptured and died. Blood spills into tissue. Dirt and debris are carried deep inside. Worse still, bacteria flood into the warm, nutrient-rich environment between your cells, multiplying rapidly and releasing toxic byproducts. Within seconds, the first stage of defense begins. Damaged and dying cells release emergency chemical signals, cytokines and chemokines that spread through the surrounding tissue like alarm sirens. These signals alert the immune system that an invasion is underway. The first responders arrive quickly. Macrophages. If an average human cell were the size of a person, a macrophage would be the size of a black rhinoceros. They are large, slow-moving, and incredibly powerful. Normally calm and observant, macrophages become ruthless when bacteria appear. They extend flexible arms, latch onto invaders, engulf them whole, and digest them internally using powerful enzymes and acids. One macrophage can destroy up to 100 bacteria before becoming exhausted, but this battle is too large. The macrophages release distress signals, calling in reinforcements from nearby blood vessels. Hundreds of thousands of neutrophils rush toward the wound. Neutrophils are extreme specialists. They live fast and die young, surviving only a few days. They are so destructive that their short lifespan exists to protect your own body from them. When neutrophils arrive, they attack without restraint. They spray toxic chemicals, consume bacteria, and tear through tissue with little regard for collateral damage. Some neutrophils go even further, rupturing themselves to release massive web-like traps made from their own DNA. These sticky nets are soaked in toxins that immobilize and kill bacteria. Some neutrophils continue fighting even after their death as the conflict escalates. Nearby blood vessels widen and become leaky. Fluid floods the area, carrying immune cells and weapons into the tissue. You experience this as swelling, redness, and heat, classic inflammation. Within this fluid are millions of complement proteins, an automated chemical defense system. These proteins attach to bacteria, punch holes in their membranes, mark them for destruction, and amplify the immune response at this point. The outcome is uncertain. If the first line of defense succeeds, the infection is eliminated quickly. But if the bacteria overwhelm these defenses, the invasion could spread and that can be fatal. This is when the dendritic cell takes action. Dendritic cells act as the intelligence officers of your immune system. While the battle raged, they collected pieces of the enemy, cutting bacteria into fragments and displaying them on their surface. Then they leave the battlefield entirely, traveling through the immune system's transport network to your lymph nodes, the command centers of immune coordination. There, the dendritic cell begins searching for a helper T cell with the exact molecular key to recognize the invading bacteria. It presents the enemy fragments to thousands of T cells. Most ignore it. Then, finally, one responds. This raises a profound question. How does your immune system already have a cell capable of recognizing a bacterium you've never encountered before? The answer lies in diversity. Your immune system generates billions of unique T cells, each with a different receptor capable of recognizing a different molecular pattern. Together, they form a library of defenses against virtually every possible pathogen, even ones that do not yet exist. Once activated, the second line of defense begins. Slowly but decisively, the helper T cell starts cloning itself rapidly. 1 becomes 2, to become 4. Soon, thousands of identical cells exist. They split into 2 specialized groups. The first group returns to the battlefield. A macrophage, exhausted and damaged after days of fighting, is close to shutting down. A helper T cell makes contact and releases activating signals. Instantly, the macrophage is re-energized. Its metabolism increases. Its killing capacity surges. Across the battlefield, immune cells regain strength and momentum. The second group of helper T cells activates B cells, your antibody-producing factories. B cells begin cloning themselves and transforming into plasma cells. Each plasma cell produces up to 2,000 antibodies per second. These antibodies flood the infected tissue, binding to bacteria, clumping them together, neutralizing their toxins, and marking them for destruction. About a week after the initial injury, the second line of defense reaches full strength. The tide of battle turns rapidly. Immobilized bacteria are eliminated one by one until the invasion collapses completely. With the threat gone, most immune cells self-destruct to conserve energy and prevent unnecessary damage. But some remain. A small number of helper T cells become memory cells, staying behind for years or even decades. Some B cells continue producing low levels of antibodies. If the same bacteria ever return, your immune system will respond faster and stronger than before. You are now immune. Days later, you notice your thumb has healed. The wound is gone, leaving only a faint red mark. You never noticed the war that took place inside you. For you, it was a minor inconvenience. For millions of cells, it was a brutal fight for survival. And this is only one battle. Every day, inside your body, countless similar wars are fought silently to keep you alive. Thank you for watching Cognitia. Stay curious. Explore deeper.